Okay, this video answer is more about how to organize your work when you're finding applying the first derivative test, the second derivative test, and the test for concavity for a given function. So here's the given function. Might as well find the first and second derivative right away using the power of the first derivative. There's the second derivative. And let's find out some details about this function. First of all, the roots are by factoring out the x to the fourth, the roots are at x equals 0 or x equals 5, which means the points 0, 0, and 5, 0 are on the graph of the function. And the end behavior, by focusing on this first term as x approaches infinity, that term approaches a positive number, a positive infinity. So to the right, the graph is upward, and to the left, it's down, because this, as x approaches negative infinity, this first term is negative. So we say it's down, up, end behavior. And here's kind of an indication that to the left, down, to the right, up. Here are the zeros at 0, 0, 5, 0. The first derivative test, we want to find critical numbers. Set the first derivative equal to 0. Factoring out the 5x cubed, we find out that the zeros, or the critical numbers, are at 0 or 4. So there's the critical numbers on this little number line, and this little line graph is depicting the first derivative tests. So when the first derivative is positive, the function is increasing. That's what this shows right here. Pick a test number in that interval to the left of 0, plug it into the first derivative. We do get a positive number because this factor is negative, so is that factor. Between 0 and 4, like pick a test number of 1. The first derivative is negative, so the original function is decreasing. To the right of 4, the first derivative is positive, so the function is increasing. So if the function goes from increasing to decreasing, that means there's a relative minimum at that point right there. I'm sorry, relative maximum, because we went from increasing to decreasing, and that's what's shown right here. Okay, and at 4, we've gone from decreasing down here to increasing, so there's a relative minimum when x equals 4, and that's what this shows right here. The second derivative test we don't need, but just to review, if you plug the critical numbers into the second derivative, that tells you whether you have a relative maximum or minimum. Well, f double prime of 0 is 0, so that doesn't tell you anything about the concavity of the function at that critical number. So that doesn't help. So we'd have to go back to the first derivative test anyway. But f double prime of 4 is positive, which means that at 4, the curve is concave upward, which means we have a relative minimum there. And that's what, again, that shows. And finally, test for concavity, use f double prime, x equals 0 or x equals 3. We used to call these hypercritical numbers, 0 and 3. I don't think they use that term anymore. But when the second derivative is negative, the curve is concave downward. Think of frown, negative. And it's still negative between 0 and 3. So this is not a point of inflection here. Concavity is not changing. But to the right, the concavity does change because the second derivative is positive, concave upward. So there is a point of inflection here, and that's what's depicted right here. Okay, so that's a pretty rough sketch. If I share my screen and go to Desmos, there's the function. There is the relative max at 0, 0, the relative minimum at 4, negative 256. There's the point of inflection. And if I enable a graph of the first derivative, there's what it looks like. You can see that that first derivative is equal to 0 at 0 and equal to 0 at 4. And that's where we have the relative minimum. But between, between 0 and 4, the second derivative, the first derivative is negative, which means the function is decreasing on that interval. So we've gone from 0, 0 down to negative 256. And if I enable the second derivative, you can see that the second derivative is negative everywhere to the left of 3. That's why the curve is concave downward. But at that point right there, the concavity changes. And we do have the up behavior. This table shows some points that you could also graph to help you sketch the curve. Okay, there you go. Hope that helped. If you have any questions, post a comment.